So the two types of energy that we're going to be able to calculate right now are kinetic energy and gravitational potential energy. These are methods of storing what we call mechanical energy. Later on, we'll add one more, which will be the elastic potential energy. We also talked about moving energy into a system and away from a system, and that was called work. Okay, so work isn't like a different type of energy, it's just the way we describe energy that's being transferred into or out of a system. And sometimes you'll calculate that by knowing a force and a displacement, and sometimes you'll calculate it by looking at how the energy changed, looking at the starting energy and the final energy and subtracting those. And then we also described that there is a rate at which work is done, so that involves time. And it's just simply dividing the work or dividing the change in energy by the amount of time that the transfer requires. All of the ideas of energy are measured in joules. So kinetic energy, potential energy, and work are all measured in joules. And then power is joules per second, which is called a watt. So here's a first question. Let's think about what formula we would need in order to solve this and how we might do some algebra to determine the mass. We'd want to begin with the kinetic energy formula, m times v squared over 2. And you could certainly plug things in and then do your algebra, or you could do a little math to start with and see that the mass would be 2 times k divided by v squared. And again, the new variable here is the capital K. That stands for the kinetic energy. Plugging everything in, making sure we square the value of speed, we would get 4 as our answer. And because we were looking for a mass and we use standard units, it would be in kilograms. If that toy airplane is known to be 5 meters above the ground, we could also find its gravitational potential energy now that we know the mass. We would use this formula for potential energy. Again, capital U is our symbol for all of our potential energies. One thing we need to remember is that the value of little g is not going to show up in the problem. We need to know that since we're on Earth, that is 10 newtons per kilogram. And so overall we'd get 200, and our standard units for energy are joules, abbreviated capital J.